I'm trying again. Okay. So, first thing, the quiz from Friday, the only section that is going to be on this Friday's quiz for an automatic retake is everybody has to redo 7.4b, which is finding eccentricity, completing the square and finding eccentricity, okay? I'm thinking I might put in, if I have room on the quiz, I might put 7.4a for anybody who needs to retake that section to get it out of the way in class. Does that make sense? But if you don't need to, you won't have to. Okay? So that would be a freebie for anybody who needs to do a retake on 7.4a. But that's all I'm going to be able to fit on the quiz, and I'm not going to do anything else. You have to come in on your own time. Okay. The learning targets on parametric equations today, we are going to have equations that have x, y, and t. It's going to be x in terms of t and y in terms of t. So you are going to have to graph these, find endpoints based on the restricted values. You're going to have to be able to eliminate a variable. You're going to have to be able to indicate orientation. That's really part of this one, which way it's going. Okay. And then we're going to do projectile motion equations at the end, and we'll do some more of those tomorrow. There was a copy of the bookwork by the door today if you wanted it. All right. Parametric equations are used when you have three things coming into play. This is an example I found online. It says, this is the wolf population over a period of years in a certain habitat. This is the rabbit population over a period of years in a certain habitat. Does it make sense that as there becomes more wolves, the number of rabbits might go down? Okay. So if we graphed the number of wolves and the number of rabbits, so for year one, there were 5 wolves and 90 rabbits. So that would be here, okay? And then for year 2, there were like 7 wolves and a little bit down to like 80 something. So that's this point. So it's going around this way, yes, because eventually when there's not enough rabbits anymore, the number of wolves, okay, etc. It's cyclical. Makes like a circle. As one goes up, the other one goes down. All right. So there are situations in real life where we want to not graph things in terms of time, really, but time is part of the process. We're going to do what these today are, when we did vertical distance formula, like we said the height of something was negative 16 t squared plus v sub 0 t plus h sub 0. Remember that? Okay. So that we call those, I called those throw up problems because you threw something straight up in the air and it came down. It doesn't really make a parabola shape. Okay. It's height versus time. Does anybody know why it's shaped like a parabola? But this is its height. It goes straight up and comes straight down. Why does it look like a parabola when we spread the time out? Okay. Because it slows down up here. Do you see how flat it gets? And then as it approaches the ground, it gets much steeper. It's falling faster, right? Due to acceleration, due to gravity. Yes. All right. If we threw that item straight away from us, its distance away from us would just, it's never going to come back, right? You throw a baseball, it just gets further and further away from you. All right, so if you graph its vertical height versus its horizontal distance away from you, so at time 0, time 1 second, 2 seconds, 3 seconds, you get an actual path of the ball, and then we can find lots of things. How far away from us does it land? When was it at its maximum height? You know, does it clear a fence that's 20 feet away? Whatever. So that's where we're going with this stuff. All right, a rectangular equation has x and y. Parametric equations are both in terms of t. X is in terms of t and y is in terms of t. The example we just talked about, t was time, but it's not always time. Okay, but they will use the variable t all the time. Always, not just time. Okay, sorry. All right, so for parametric equations, we can determine where the object was at any given time by evaluating the horizontal and vertical components. For example, when time was 0, the object was 40 feet up. The variable t is called a parameter. This is graphed over the interval 0 to 4. And can you see these are little arrowheads in here? Okay. It's showing the orientation or path of the ball, that it started and went this way. Because it's possible, guys, we're going to get graphs that look like this. Okay. And the orientation is starting lower right and turning around and going this way. So we have to put arrows on there to indicate which way it went. All right, so again, parametric means x in terms of t and a y function in terms of t. What happens? Is the resulting answer going to be a function necessarily? No. Okay, so let me explain what happened here. We took a little table and included the values from -4 to 4. Started here, counted all the way down to here. Then we put all of those t values in here to get an x coordinate. So here. So we put in -4, we squared it, got 16 plus 5 was 21. Does everybody see where these came from? If I put a 0 in here, 0 squared plus 5 would be 5. If I put a 3 in here, 3 squared would be 9 plus 5 is 14. You see where those values are coming from in that x column? Okay, then you take the y, and what variable are we putting in here? T again. We're putting these numbers again into this. We're dividing by 2 and adding 4. So -4 divided by 2 is -2 plus 4 was 2. We got down to 0. 0 divided by 2 is 0 plus 4 was 4. We were over here at 3. 3 divided by 2 is 1.5 plus 4 is 5.5. But when we go to plot them, we don't plot t. You plot the ordered pair 21, 2. And then you plot the ordered pair 14, 2.5, and then 9, 3, and then 6, 3.5, all the way through. So this is where we started, and this is where we ended. Those are called endpoints, but the endpoints are determined by this measure right here, right? Because they told us to go from -4 to 4. If we'd gone from 0 to 4, we'd have different endpoints because it would have started at 5, 4 instead. All right, notice that what we get at the end is not necessarily a function. Was going sideways, it failed the vertical line test. All right, we're going to try this one, and we're going to see how my tablet works because it hasn't worked well all day. All right, so the rule for x, first of all, it said to go from -3 to +4, and that's why these values are in the chart. Does everybody see that? On the quiz, those values aren't going to be there, and you're going to have to pick your own values. But if I give you this piece of information, you should be able to do that, yes? Okay. So for the x, we're supposed to take -3 and add 4 times the t. So if I put a -3 in there, 4 times -3 is -12, plus a -3 is -15, I think. How'd I do? Okay, put in a -2 times 4 would be -8, and then plus -3. You know what? I'm going to rewrite this. Isn't that just 4t minus 3? I'm just rewriting this just to make it faster. So 4 times -2 is -8, minus 3 is -11. What's -1? Put in a 0. -3, put in a 1. 4 minus 3 is 1. 8 minus 3 is 5. Put in a 3, and we'd have 12 minus 3 is 9. 16 minus 3 is 13. Everybody know where I got those? Now the y rule says to take t squared and add 3. So square this and add 3 and we'd get what? Now we're not using the x at all, we're using this t. So negative 3 times negative 3 is 9, plus 3 is 12. Negative 2 squared is 4, plus 3 is 7. What about negative 1? 0. Positive 1. Positive 2. Yep. 3 squared is 9, plus 3 is 12. 16 plus 3 is 19. All right. The endpoints over here should be the values at the ends of our interval. So the ordered pairs are at negative 15, 12. And where did we end at? Ordered pair 13, 19 down here. All right. This is like a nightmare for Hofbauer with their bifocals, but we're going to try to graph this. Starting at the top, the first ordered pair was at negative 15, 12. I have no idea if that's right. Negative 11, 7. And we're going this way, so probably as we go that way, we should put a little arrow on there to indicate the orientation. We were going kind of down and to the right. Then negative 7, 4. Negative 3, 3. Positive 1, 4. Over to 5, 7. Nine, 12. And 13, 19. All right. And you just need at least a couple arrowheads on there to indicate the direction. There's no magical number of arrowheads you need. I'm not sure how accurate mine is, but did everybody get something that looks kind of like this? All right, what we wound up with is a parabola. The next thing we're going to talk about is rewriting this into an equation of a parabola that's called eliminating the t. Any questions about how we got any of those values on that? Okay. So this is an example of eliminating the t when you don't have this, so just look up here real quick if I can get it to work. So there's this equation for x and this equation for y. I need to get one of the t's by itself and substitute into the other one for the t. So I don't have a t anymore. Okay? If I wanted to isolate t here, I would have to subtract 2 and square root. Does everybody see what I'm talking about? That'd be kind of messy, right? Because you'd have to have a plus or minus. So I'm going to do it this way instead. I'm going to get the x by itself. I'm sorry, the t by itself in terms of x. What will that say? How do you get that t by itself right there? X over negative 3 equals t. And then I'm going to put this in here. Y equals x over negative 3 squared plus 2. Did I just get rid of t? Okay. Now, if you really, this is really just an x squared, but when you square negative 3, you get what? 9, and it's in the denominator, so it's like 1/9 x squared plus 2. All right, so let's try. Notice when you did this, guys, it doesn't matter which one you do, y or x, but it's easier sometimes for one than the other. Did you have this one? Oh, this is a different one. Okay. This one you have, it's not the one I just did though. It says, again, this one has a squared in it, so you probably don't want to have to get the t by itself here, or it'll have a plus or minus. If you get the t by itself here, what would you do? Add 2 and then divide by 4. So they got this. And then they substituted in here and got this. Now, just to make it look more like we're used to, I'm going to leave the x plus 2 quantity squared. But when you square 4 in the denominator, you get what? 16, and I'm going to write it out front as a 1/16. And then the plus 1. What? Yeah, but you're not, it says an equation in rectangular form, which means it's going to have x's and y's in it, okay? Now, if we wanted it in the form we were doing this last week, you would subtract the 1 over here. And then you could divide or multiply by 16 over to this side. Does that look like the form we had last week where we had 4p, y minus k, and x minus h squared? But this one is fine. All right, so let's try the one we were just doing. This is the question from up above. Do we want to get the y in terms of the t by itself here or here? Yeah, the x one. What's that going to say if we get the t by itself? Okay. And then we're going to put this in over here. X plus 3 quantity over 4. And we're supposed to square that and add 3. So yes, we've talked about that you could leave the x plus 3. But if you square the 4, you get a 1/16 plus 3. This is vertex form, guys. Remember vertex form from beginning of the year? Where's the vertex? What's HK? Right? HK, negative 3, 3. Can you just go back to our picture for a second? Did this look like the vertex was maybe at negative 3, 3? Okay. So we found the equation of this green parabola when we eliminated the t. Here. All right. We're going to try one more by hand. If I put this on the quiz, I would expect you to make a little table that had what values, or I would actually give you a table, but okay. T, X, and Y. And it says here, like Eric said, we need negative 4 to 4. Okay, how are we going to find all those X values? Yeah, it says we're going to square the T and then add 4. So if we square negative 4 and add 4, we'd get what? 16 plus 4 is 20. 9 plus 4. 4 plus 4. 1 plus 4. 0 plus 4. 1 plus 4. 2 squared is 4 plus 4. 9 plus 4. And 16 plus 4. Everybody good? I'm going to show you how to let the calculator do this for you in just a second on the next problem. All right, what's the rule for y this time? It's a little messy. T divided by 2 minus 3. Okay. Remember you're using t, not x. Everybody good with that? That's the most common mistake, is they use the wrong number. So negative 4 divided by 2 would be negative 2 minus 3 would be? Okay. Negative 3 divided by 2 minus 3 more would be 4.5. Is that right? Okay, negative 2 divided by 2 is negative 1 minus 3 is negative 4. Do you notice what's happening? Yeah, this is linear. The y definition is linear. It's going down, so we could just cheat and go negative 3.5, negative 3, negative 2.5, negative 2, negative 1.5. And let's check this one out. If we put a 4 in, divided by 2 is 2, minus 3 is negative 1. Did it work? All right, when we go to plot the points, what are we plotting? So it starts at 20, negative 5. This is counting by 2's going across, 2, 4, 6, okay? And the graph paper going down is going down by 1's. Pretty good. So over to 20 and down to negative 5 is here. The second ordered pair is 13, negative 4.5. So my orientation would be this way. 8, negative 4. 5, negative 3.5. 4, negative 3. 5, negative 2.5. 8, negative 2. 13, negative 1.5. And 20, negative 1. Did you get a sideways parabola? Anybody tell me where the endpoints were? And those endpoints were determined by what? Yes, by this interval given in the question, right? If they gave us 0 to 12, would the endpoints change? Yes. Would have started at, if we put in a 0, we'd get 4, negative 3. We didn't go out that far. All right. Any questions? So you could do one of those by hand? The same question is going to ask you to eliminate t. Yep, apparently I didn't do that till later. Okay, let's look at one on the calculator now. Ready to try this? Okay, what you need to do is go to the mode on your calculator. Turn your calculator on and go to mode. We are going to want degrees in a few minutes, so go ahead and put your calculator in degree mode while you're here. Okay? And then go down one below degree. Do you see it says function and then par, pol, and sec? Okay? That stands for function, parametric, polar, and sequence. By the end of April, we're going to have done all of those. Today, we're doing parametric. Now, before you get off this screen, I want you to look at your X key down here. There are 4 things on that key. X, T, theta, and N. Next to the green alpha. Do you see the key I'm talking about, guys? This guy right here. Okay? Those 4 things correspond to the mode it is in. When you were in function mode, that button gave you an X. Now that we are in parametric mode, that button is going to give you a T. When we put it in polar mode, it's going to give you a theta, and we put it in sequence mode, it's going to give you an N. That's why it has 4 things on it. Okay? All right, I want you to go to y equals. You're going to see some crazy business here. Okay. X equals, or y equals, is now x in terms of t and y in terms of t. All right, so for the question we're doing right now, we're supposed to put a rule in for x that says t divided by 2. So we're going to type t divided by 2. And then we're going to arrow down. And for the y rule, we're supposed to put square root of t plus 2. Make sure when you put square root of t, yeah, the plus 2 is outside the parenthesis or outside the little box if you have the updated operating system. Everybody got it? Okay, we're not ready to graph this yet because we have to set up what the T window goes from 0 to 9. That is part of the window. We're going to put 0 to 9 for the min and max. Okay. Can you just think with me for a minute here? When we made our little table, we counted by ones, right? So you could put a 1 in here and it would work. The T step is how often the calculator is going to calculate as it goes from 0 to 9. I usually leave it 0.1. Okay, it's going to do 10 calculations between 0 and 9 and plot them and connect them. You don't want to do something really, really tiny, okay, because it will take the calculator forever to graph it. It's a tenth. It's not that tiny. If you put in 0.01, then it has to do 100 calculations as it goes from 0 to 1. Okay? 10 does 10 calculations. That's not that bad. 0, it's going to go put in a 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. It did 10 calculations from 0 to 1. So from 0 to 9, it would do 90 calculations. Okay? But it will go pretty fast. It's a calculator. If you put in 0.01, though, and it's doing 900 calculations, that's a lot longer. Okay. Most important of all, don't put in a huge T-step, because then it will only find 1 or 2 points and connect them. And that's not going to look anything like a smooth curve that we need. Okay? Going down here to the Y, what does it look like my graph paper is? Going from like, okay, going across, that looks like -2 to something. How far does it go across? I'm going to put 10. Good enough. Doesn't go out to 10, I don't think. -2 to 10. The Y goes like -3 to, what did you say? I'm just going to put 10 again. All right. So somehow you need to make sure it fits in your X and Y. And the scale doesn't matter. 1 is fine. Then you can hit graph. It does?
Yeah.
Go back to window. 0, 9.1, -2, 10, 1, -3, and 1. Okay, go to Y equals. T divided by 2, square root of T, close parenthesis, plus 2. Okay. Oh, wait, go to your Y equals again. Do you have any of these at the top darkened in? Okay, turn the plot off. Okay? Did everybody get it to work? All right. If you want to see the ordered pairs, guys, you have a couple options. You can trace along and find some ordered pairs, or you can go to the table. But before you go to the table, make sure if you go second window, make sure it says 0, 1, auto. Go second window, 0, 1, auto. Okay, then if you go over second graph and look at the table, you can find ordered pairs. All right. If you trace along, where is it at 0? Okay, at T equals 0, it's at 0, 2. So that's an endpoint. Okay. Now, the only thing you're allowed to change in this mode is the T value. So as you trace, you have no control over X and Y. You can only change T. If you go until T is 1, what does it say? What does it say when T is 1, guys? 0.53. Okay. I'm just going to go out here ways, find maybe where it is at 4. It's at 2, 4. And then maybe I'll just go to the end. Now, where does this end? It should end when t is 9 though, right? Because that's where our, which is at 2, 4.5, 5. All right. So the endpoints were at 0, 2, and it was at 4.55. Where's the other endpoint? Any questions? If you just let me show you what happens if I put the t-step, everybody looking up here, if I put the t-step as like 5, well, it's only going to calculate how many points are there between. If it goes 0, 5 later it puts in a 5, 5 later it's at 10, but you want me to only go till 9, right? So it only found 2 ordered pairs. If I put the t-step to be really, really tiny, like 0.001, yes, you'll just sit here and watch it, and eventually it might start to graph a little bit of a line, okay? Or a piece of your parabola, but it's going to take a really, 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 really long time. Yeah. So it's starting right there. I don't know if you can see it, but it's not going anywhere fast. Yes. You can just graph it as long as you graph it. On the quiz, I actually gave you a table. So you got to fill the ordered pairs in, okay? No, guys, how do you break what it's doing? Just hit on, then you can do anything you want, okay? Just hit on, you can go clear, whatever. On breaks what it's doing. Okay, let's go back. I'm going to go back to this number 1. How would you get this to say either x equals or y equals? How would you eliminate the t? We need practice with eliminating the t. This doesn't go well for students. Okay, so you want to make this y plus 3 equals t over 2. So 2 times y plus 3 equals t. And then we can plug that in where? Here. So we'd have x equals 2y plus 3 quantity squared plus 4. I would be fine with that if you wanted to get it to look more like what we did last week. You would subtract the 4 over there. Oh, you're right. It was this whole thing squared. Thank you. I was thinking it wasn't giving me the same thing as last period. All right, so we'd subtract the 4 over there, and then we'd have a 4 and a y plus 3 quantity squared. If we divided the 4 over, we'd have 1/4 x minus 4, which you don't have to do any of this. But is that the form we had last week for a sideways parabola, guys? Whose vertex was at 4, -3? 4, -3 right there, right? Okay. What about number 2? How could you get the y by itself here, or get rid of the t? So you would have 2 2x equals t, so you'd have y equals what? Yep, just put this in here. You'd have y equals square root of 2x with a plus 2 on the outside. Okay? Just wanted to practice that. So what about these two real quick? This will be x minus 3 equals 2t. Or do you want me to do this one? You want to do this one? Just make this one y plus 4 equals t. and then put that in over here, because it says to down here. Yeah, I'm not helping. No, let's try again. What does it say to do down here? It says to get the y. So we got to do this one and put it in here. All right. So x minus 3 divided by 2. And then we're going to put this in here. So it's going to say y equals what? X minus 3 over 2 minus 4. If you wanted to mess around with that, you'd have 1/2 x minus 3/2 minus 4, which would be 1/2 x minus 11/2, I think. But it's fine. What we had here is beautiful. I don't care. All right, what about this one? What's t here? T equals x minus 5. If we plug that in here, we'll have negative 3 times x minus 5 quantity squared. Just leave it. All right. We're going to get started talking today about projectile motion. All right. When we did these in the past, we had this formula. The height equals negative 16t squared plus v sub 0 t plus h sub 0. That was when we were throwing something straight up or down. I called them throw up problems. They were back in the quadratic unit at the beginning of the year. Okay? The problem is very rarely do you throw something straight up in the air. Is that true? And is there a sport where you throw something straight up in the air? Not very often, right? Okay. You throw something at an angle to the ground or at an angle to the floor or whatever. You throw something at an angle to the horizon. So we're going to use these formulas. This is right on your green sheet, okay? Now, it says here negative 1/2 g. As long as we're in feet, that's just negative 16t squared, okay? If we're in meters per second, I think it's negative 9.8, but it'll say on the question. All right. Okay, but you care about the angle at which it goes across the net, right? Not. All right. Anyway, this is an example, guys. I'm just going to go through this as though I were doing it. It says, Kaylee's practicing free throws for an upcoming basketball game. She releases the ball with an initial velocity of 24 feet per second at an angle of 53 degrees with the ground. So the formula off the sheet says x equals t times her initial velocity times the cosine of the angle. It says y equals t times initial velocity times the sine of the angle. And then it says minus the gravity coefficient times t squared plus initial height. It says she releases the ball 4.57 feet from the ground. 4.75. Okay. So I don't know. Okay. I don't really know. But all right, so I type it in, guys. I typed this all in, okay? I said 0 to 5. Why did I pick that? I was pretty sure the ball was going to come down before 5 seconds, right? All right, I put in 0.1 for the t-step. You might as well just learn to use 0.1 all the time for your t-step. It's fine. I put in 22 for the distance away because it said up here the front of the rim's 13 feet away, so I just picked something. All right. Anyway, then it said, does she make the basket? Well, if the rim is how far away? Okay, the rim is 10 feet up, but it's 13 away from her. So I traced out till I was 13 feet away from her. You see down here, 12.999? When it was 13 feet away from her, it was 9 feet in the air. If the rim is at 10 and her basketball's at 9, she got an air shot, right? She didn't even hit the rim. Okay. Air ball, yes. Air shot. I don't know what I'm saying. All right. We're going to try this one. Quick. What is the x equation going to be off your sheet? It says t, so we're going to have to plug in a t, times the velocity, which is 35 feet per second, times the cosine of 48, and we need to make sure we're in degrees. Y is t times 35 times the sine of 48, and then minus 16t squared plus 2 feet above the ground when he kicks it, right? All right, how fast can you type those in? T cosine of 48. Scroll down. Oh, I forgot the 35. T times 35 times the sine of 48, close parenthesis, minus 16t squared plus 2. Okay, this time, I don't think it's going to take 9 seconds for the ball to come down, but I can leave it 9, doesn't matter. T-step point 1. I think the ball might go, I don't know, 70 feet away from me. And it's going to go up, I don't know, maybe 25 feet in the air. All right, so it worked, fits in my window. The question is, how far will the ball travel horizontally before it hits the ground? So if I trace along till it hits the ground here, how far away is it? 40. Yes, 39.8 or around 40 feet away. Okay, I used 0 to, I don't know, I think I had 9. And it took about 1.7 seconds to hit the ground. All right, so we'll do some more of these tomorrow. And this is the assignment.